gotten the basic frame and the loop and the shaft in there. The center of the generator, the actual workings are Honda generator. It has a permanent magnet coil in it. If you turn it over, you feel the cogging as it lines up. So I'd seen one of these at another member of the GGLS had one, and I thought this was very cool. So when I saw this on the shelf over there at the Armstrong house, I said, yeah, and that too. So what was done came apart, and everything got cleaned up and sandblasted, and then paint and everything. But where most of the work is of course in this front part, and this front part actually doesn't do a damn thing. It's all decorative.
Oh, really?
Yeah, everything is already there. In fact, the friend of the GGLS told me, he said, well, on mine I didn't even do that.
Oh, but that really makes it look good.
But well, I was impressed with all the coils and stuff as you see it on the back. And in fact, I turned the generator coil, the stator, around backwards so that there's something to look at on the back of it when you're looking at it. I didn't like the parts that were supplied by the original designer for the ring and the supports and all of that, so I cobbled it up out of other stuff. The little brush holders are all bits of brass, all silver brazed together, and this just turned from plate. And I actually used carbon for the brushes because I had it. The designer suggested just using a black plastic, also the support in the original design is just bolted down. But looking at the old textbooks, I have some of the information on the shelf. All of the old dynamos, this ring could be rotated somewhat.
Yeah.
And there was a crank on it, which is a feature I did not add. I may go back and add it at some point.
The worm gear or something?
Yeah, there's you can just tilt it by a couple of degrees or half a degree, and I guess that's a voltage regulation arrangement on it. But so what I ended up doing was making my own brackets to hold it, and then machining them so I could get this motion in here. Which was, for me, was kind of tricky. I was trying to figure out how to machine those and get them accurate enough to hold that with just a small section holding it. And my solution was, initially I'd put the ring in the lathe with these brackets on it, and I started with in the lathe, and it's going tink, 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 which is always that sound of you're going to fail. You've all been there, you know. Tink, 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 bam! So I said, no, okay, I don't want to make more brackets. So what I did, I put it on a rotary table and used a cutter and spun the thing around and cut them out that way. And the wire is antique wire.
Yeah, where do you get that?
Oh, that was salvaged out of old stuff.
Ah.
Yeah, I've got this garage full of crap. You've never seen it.
Oh, I've been looking. I tried, yeah, I looked at
Coils. This past month, I've been working on the oil circuitry. There's oil pumps in the oil pan. And this is the output of the oil pumps. There's let's see. Pressure regulator goes here. Two-stage pressure regulator, and so there's a lot of oil circuitry here besides just going into the crankshaft. So there's one tube that goes up here to the propeller reduction gears, and so that's what this tube is for. This one above it goes to the heads to oil the camshafts. And this one back here goes over to the gears that power the supercharger.
What diameter tubing is that? Pretty damn small.
It's an 1/8 inch.
Oh, okay.
Yeah. So there's actually two aspects to all of these. One is getting the oil there, and the other is draining the oil back into the oil pan. So up in the front, there's a little hole here where the oil pools at the bottom of the gear case, and the drill makes a hole that goes back towards the oil pan. And same thing in the supercharger gears. There's a little oil drain hole down there that lets the oil from the supercharger gears drain back into the oil. And then for the heads, the oil that collects in the heads, just like in the full-size engine, the holes for the studs that hold the heads and the blocks onto the crankcase are oversized, so the oil can flow down those holes. But to get there, there's some angled holes in the head. You know, there's a nut on the top of the stud, so that hole is sealed. So the way the oil gets in there is off to the side of the stud. There's a hole drilled at an angle that goes into that hole.
Did they do all the suds or just a few?
I just did the ones on the ends.
Oh, okay. Was
Because
that
the
the
engine's either going to be a little bit nose down or a little bit nose up. And I only did them on the outside because the heads are tilted.
That engine, didn't it have a dry sump? Wasn't it a dry sump engine?
Yes, dry sump. And then they had a 27-gallon oil tank separate from the engine and oil coolers. On the Mustang, there's one oil cooler and an oil scoop.
The Spitfire, you
And
know,
the Spitfire,
it
yeah.
isn't as obvious, but it has a little thing down there
it's got
too.
one down there.
On the Spitfire, there are two coolers, one on each wing.
Okay.
I don't know. The Spitfire might have separate coolers for the water and for the oil. My
It's a good thing to
recollection on
keep
the
them
Mustang,
apart.
they're both in the belly. Straight, unregulated oil goes to the crankshaft and to the propeller. Not to the reduction gears, but to the variable pitch hub. And it actually goes into another pump. So full pressure oil from the main oil pump at full pressure is on one side of the hydraulic variable pitch piston, and then additional pressure from the extra oil pump applies pressure to the other side if it's trying to push it one way, or to this side if it's trying to feather the prop the other way. And then
A bash valve engine, meaning when the piston comes down, it pushes open this valve. I'll pass the valve around. You'll see that it has 50 thousandths grooves in the shaft here, and 50 thousandths holes that were just printed through this. And the only thing that's lacking now is to be polished. So
You're gonna chemically polish?
no, put it, hook it up in an electric drill and a little sandpaper, and away we go. But you can see the bottom, which was printed directly on the build plate, is shiny, and that's how shiny you can make this stuff, and it's very strong. But then I had originally planned, basically, steam cylinder shaft goes in here, you know, with all the normal crankshaft stuff, and then this is the valve chamber, and the valve slides right down in there, and then it sticks up And when the piston comes down, it opens it up. But you want it to seal, and I thought O-ring would do it. Well, it's too hard. So I had to make, I don't know what you call a valve seat, I guess, which meant I had to make one of my least favorite things to make, which is a concentric punch. And I had this epiphany, which probably everybody else has had too, is you cut the taper first and then bore the hole. Because if you do it the other way around, try to get that edge sharpened, I always curl it. And then you got this problem of, what do you do now? Throw it away and start again. So basically it's just concentric. You punch the center one first, setting it on this material, and then pull it out or leave it there, and well, you got to pull it out, hit it again, and you're through. So I got a magnet on this to keep them together. But that's just 12L14, and since I'm punching soft silicon sheet, $10 from Amazon, of course, the machinist supply, it works really great. And it takes just a heartbeat to make them. So
On the smaller one, how did you do that one, the inside edge?
that's basically a center drill,
Oh, okay.
because you don't care. I mean, it's really
It
thin
looks
stuff.
steeper than the center drill angle, I just wondered.
But it works. But cut the taper first, and then do the ID or the OD, depending upon which way you want to punch it. And of course, you want where you're going to have a surface on it. You end up printing it on the bottom of your vat, which does no good. So I cut grooves in here so that the stuff could get it through there, and it wouldn't be quite so much, if you will, suction, as they say. Because what you have is a vat with a plastic film of Teflon, and when this thing picks up off there, it picks the film up, and then finally it pops free. If it doesn't, then you print on the film for the rest of the print job.
So it's a relief group.
1988, and this thing predates that probably about 20 years. So I've had it around a long time. And one day I was digging around in a drawer, and I found it in there again. I thought, I got to do something with it. So I set it up to run it, and Peter said he had a use for it.
No, what I said is I figured out what it came from.
Yeah, but anyway, you said you wanted it.
Yeah.
So I decided I'm going to give it to Peter, unless somebody else wants it. This came out of a Mark 14 torpedo, and there were two of them in there. There was a right hand and a left hand, because the torpedo had two props. They were turning in opposite direction, and they were powered by steam, but steam was made by a chemical reaction, and I don't know what kind of stuff they used it.
They just burned kerosene.
But anyway,
And then injected water into the combustion chamber.
Well,
Yeah.
actually, it was called Pink Lady, and it was alcohol. And the sailors used to
Sailors
try
would
to
know about
filter
that.
that to try to drink it.
so anyway, the Mark 14 had a range of about 4 miles, I think, 4 knots, four
Nautical miles?
whatever it was, and the speed was also around 40 knots. They were pretty fast, and so I've run this thing up here. I've tacked it, and the best I've got able to get it up to is about 6,000 RPM, and I've had it up to 6,000 probably 40 or 50 times. Because everybody comes over and wants to see it run, so I think.
Does it get that
We
way?
got it.
And when I got it, all I had was a wheel, nothing else. So I put a couple of bearings in it and built something to hold it so I'd run it. And unfortunately, I don't have the air here to do that.
We have the air, but we don't have the
Yeah,
hoses.
Yeah.
Right there.
No, I mean.
Oh, the breathalyzer. Go ahead, anybody?
Now, all I do is stick my air nozzle in there and run it, and it runs up, and then it'll coast for about 10 minutes or something like that.
Yeah, those, you think that's not very big, how can that power something? But if you've ever been into one of these water-powered mills, that has a Pelton wheel, big machine shops will go around off a wheel this big.
Yeah.
You go, whoa.
unless they're running at high RPM.
Yeah. Yeah,
Well, you can't run those at very high RPM in this case, because you're even if you gear things down, you get problems with cavitation in your torpedo.
well, I don't know how fast they run, but I know I run up at least
Cavitation is
6,000
metal
RPM.
removal.
And it just sits there and
Cavitation is
hums.
in
It
metal.
doesn't vibrate or
Doesn't
shake
make
or
any
anything.
difference, you're only gonna use it once.
Yes, but you're losing propulsion at the same time.
Well, I guess that's it, unless somebody else